I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
With its historic investigation of Neptune, Voyager achieved an unimaginable finding on August 25, 1989, the first spacecraft visit to the far-off planet. What if, on its trip outside the well-known boundaries of our solar system, it comes across events that contradict the laws of physics? Join us as we investigate the mysteries left behind by Voyager's groundbreaking space exploration missions, which carried mankind into previously unexplored regions of space. Discovering the mysteries of the solar system's fastest storms beneath its serene, azure exterior lies a disorderly realm. The scientists are still baffled by that. The discovery of Neptune's great dark spot, a massive storm roughly the size of Earth, was among the most startling. The highest documented wind speeds in our solar system, 2,400 kilometers per hour, were attained during this storm. What's going underneath Neptune's surface is called into serious doubt by this. Do these intense storms have any hidden mechanisms or heat sources? Researchers uncovering the secrets of Neptune come across abnormalities in the planet's magnetic field that go against accepted science. What they are going to discover has the potential to completely alter planetary science textbooks and to upend our preconceived ideas about what is feasible in the frigid outer regions of our solar system. Unlike other moons in our solar system, Triton is unique. Its orbit around Neptune is counter to the planet's spin, indicating that it may have been caught from somewhere else in space, possibly the Kuiper Belt. Triton is a freezing world with unexpectedly high levels of activity. Triton is the coldest known object in the solar system, with temperatures as low as -235 degrees Celsius, although life nevertheless exists on its surface. Sharp ridges, a pinkish icetop, and nitrogen plains were observed by Voyager 2. The geysers, which send black plumes several kilometers into the sky and are probably the result of cold volcanic activity, were the most amazing sight. These geysers provide evidence that heat may be produced deep into Triton, maybe as a result of Neptune's gravitational attraction. The surface of Triton, with its ridges and patches of smooth material, demonstrates to us that it is still dynamic and changing in its own peculiar way. It posed fresh questions even as it passed Neptune and Triton. What fuels the enormous storms on Neptune? How can the delicate ring arcs on it remain in place? What's going on beneath the cold surface of Triton? Scientists are still motivated to investigate the farthest regions of our solar system by these mysteries. While Voyager 2 bid farewell to Neptune, Voyager 1, its twin, was engaged in a distinct mission. Voyager 1 departed from Earth to explore space after stopping at Jupiter, Saturn, and Titan, the moon of Saturn. Reaching the furthest location impacted by the Sun required 32 years. As it drifted by Neptune in 1939, it took what is arguably the most iconic picture in history. Earth appeared as a small, light blue dot from a distance of 6 billion kilometers. Carl Sagan's description of this sight served as a reminder of how little and vulnerable our planet is in the grand scheme of cosmos. When these aged probes were first launched in 1977, their primary purpose was to investigate the outer planets. However, they have pushed into interstellar space, considerably exceeding those objectives. Now, long after we lose communication with them, they will continue their mission as they drift toward far-off stars. In almost 40,000 years, Voyager 1, now traveling at 17 kilometers per second, will pass close to a star in the Camelopardalis constellation. Following a different route, Voyager 2 will pass over Ross 248, a star, and thereafter get close to Sirius, the brightest star in our sky. The golden recordings that both Voyagers are carrying are chock full of sounds and visuals of earthly life, including music, ambient noises, and multilingual greetings. These recordings serve as a picture of our current state of affairs as well as messages for hypothetical extraterrestrial civilizations. The tale of humanity's search for knowledge is carried by the Voyagers as they drift farther and further away, serving as a constant reminder of our amazing adventure and the limitless opportunities that lie ahead. The information that the Voyager spacecraft returned altered our understanding of the distant planets and demonstrated the true complexity of the heliosphere, the region that surrounds our solar system. Their findings have opened the door for new missions and demonstrated the necessity of using increasingly more sophisticated spacecraft to investigate the furthest regions of our solar system and beyond. These expeditions pique our curiosity about what's out there and serve as a reminder of how vast the cosmos is. Voyagers 1 and 2 are prime illustrations of our curiosity. They inspire us to seek for that which we do not yet comprehend and to look beyond what we now know. The Voyagers represent humanity's incredible achievements and our continuous search for our place in the cosmos as they go farther into space and beyond our solar system. They will continue to inspire explorers, scientists, and engineers in the years to come. The Voyager's voyage laid the groundwork for future space travel, inspiring us to set higher goals and dream greater than before. These spacecraft, which are still in use today and are traversing vast expanses of space, serve as a constant reminder of humanity's desire for exploration and knowledge. This was crucial as transmissions between Earth and the Voyagers take hours to travel, and the spaceship needed to be able to handle issues and complete jobs without waiting for orders. Our knowledge of planets like Jupiter, Saturn, Uranus, and Neptune was constrained by the capabilities of telescopes prior to these trips. The Voyager spacecraft provided us with our first up-close view of these enormous planets, illuminating their whirling atmospheres, violent storms, and moons in ways never previously possible. For instance, the enormous storm known as Jupiter's Great Red Spot was displayed in amazing clarity. Scientists were able to learn more about Jupiter's magnetic field and its interactions with its moons because of the spacecraft's ability to record the motion of its clouds. Astonishing detail was also discovered about Saturn, the planet known for its rings. The Voyager's crisp photographs demonstrated the ring's structure, gaps, and interactions with Saturn's moons. The surprises, however, didn't end there. Scientists now have a better knowledge of the atmospheres and geology of Uranus and Neptune because of their up-close observations of the planet's peculiar tilt and its powerful storms, which include the Great Dark Spot. Strong winds and a continuously shifting environment were unique features of Neptune that made them exceptionally interesting. Our next major adventure, traveling into the stormy atmospheres of Uranus, where more cosmic riddles lie, begins with the investigation of Neptune. Voyager Mission Insights. The missions also revealed significant information on the moons that circle these planets. For instance, the thick coating of ice covering Jupiter's moon Europa may conceal an ocean beneath, which begs the issue of whether life may live there. Methane lakes and a thick atmosphere were detected on Saturn's moon Titan, while geysers were identified on Neptune's moon Triton, suggesting that the moon's surface may still be active geologically. New moons and weak ring systems, such as the narrow rings surrounding Jupiter and Neptune, were also discovered by the Voyagers. We now have a better grasp of how planets and their rings develop thanks to these discoveries. They also offered crucial details on the magnetic fields of these planets, such as the tilted magnetic field of Uranus, which startled scientists and demonstrated how intricate these planets' interior dynamics may be. Ultimately, the Voyager project symbolizes humanity's ongoing quest to understand more about the cosmos and is not merely about scientific discoveries. Each piece of information that has been returned has increased our understanding and prompted additional inquiries. Voyager takes with it our insatiable curiosity and desire to explore the uncharted, even if it is now far from home. Scientists now have a whole new perspective on the inner workings of the planet and its deep interior activity because of Neptune's magnetic field. The spacecraft entered an area where space itself starts to alter and the solar system's outer edges start to lose their power. However, it did more than just vanish into thin air. It sent back crucial information from the most remote regions of our cosmic neighborhood. It monitored magnetic forces, unseen particles, and the thin atmosphere that exists between stars. This contributed to our understanding of the boundary between interstellar space and the solar wind from the Sun. These findings helped us comprehend a hitherto undiscovered region of the cosmos and advanced our knowledge of the solar system's periphery. Despite being far outside of our solar system, the spacecraft continues to teach us new things. The information acquired helps scientists understand how planets develop, function, and interact with one another, laying the foundation for future expeditions. The most astounding aspect, though, is not yet over. The information returned serves as a kind of manual for upcoming space travelers. The accomplishments have altered space exploration in general as well as science. The lessons learned have a big impact on today's space missions. It established the bar for everything from keeping a spaceship operating over vast distances to communicating across billions of miles to maintaining equipment in the void of space. The New Horizons mission, for example, used technology and procedures enhanced by its success to approach Pluto. It demonstrated how difficult it is to communicate with spacecraft located millions or perhaps billions of kilometers distant, yet it is possible. It demonstrated that, even at great distances from Earth, large antennas and unique techniques for amplifying weak signals from deep space can be used to transmit back crisp data. However, the true test lay ahead. These methods became much more important for subsequently planned missions such as the Mars rovers or extrasolar probes. It made some of the most significant findings about the outer planets, Jupiter, Saturn, Uranus, and Neptune, when it came to planet exploration. Future expeditions should investigate the additional questions raised by the up-close perspectives. For instance, research on Jupiter's atmosphere and Saturn's rings led to further exploration of these planets' secrets by missions like Cassini and Juno. A map that has been established has served as the basis for learning more about our nearby planets. This one image came to represent our position in the cosmos and inspired curiosity about what else may exist. It increased the standard for space mission planning. Its accomplishment demonstrated the need of meticulous preparation and original problem solving. Since then, every spacecraft launched has profited from the lessons learned along the way, enabling future missions to be more equipped to face the challenges that lie ahead. Its legacy is being carried out by missions such as the James Webb Space Telescope, which seeks to probe much further into space to understand the formation of planets and galaxies. The biggest surprise, though, wasn't this. It also heralded in a new era of space travel. Europa Clipper, a mission to investigate Jupiter's moon Europa, is another one that was influenced by it. There could be an ocean under its frozen surface that might support life, according to scientists. Scientists are now looking for evidence of extraterrestrial life because of their curiosity about places like Europa, sparked by earlier discoveries about the moons of the outer planets. What was started is being expanded upon by future space missions that want to depart our solar system. As they continue to explore interstellar space, these next-generation probes will be collecting information about the uncharted regions of the cosmos. Its work serves as a foundation for the concepts and technologies guiding these missions, demonstrating the breadth of its influence. Beyond its contributions to science, though, it represents human curiosity and the urge to investigate. The golden recordings that were put on board, with audio and visuals from Earth, were dispatched with the expectation that intelligent entities might one day find them. These recordings serve as a constant reminder of our aspirations to establish contact with extraterrestrial life, even as it drifts further into space. We are genuinely curious about and yearn to communicate with intelligent species on other worlds. We wish to communicate our identities, cultures, aspirations, and future goals. They carry more than just scientific equipment when they leave our solar system. They also symbolize human desire. Their voyage demonstrates the progress we've made in our quest to comprehend space and our role within it. Their golden records, which contain messages that transcend Earth, stand symbolically for this dream. Our desire to connect with people beyond the stars is reflected in these recordings, a desire that keeps us motivated. With this understanding, we eagerly embark on a new period of adventure, wanting to see what is waiting for us over the horizon. Earth's salutations to the cosmos. The Voyager missions serve as a reminder that exploration is about more than simply discovering new locations. It's also about altering our perceptions of the universe and ourselves. These missions inspire us to keep searching farther, posing more challenging queries, and exercising fortitude when confronted with uncertainty. The golden recordings, which date back to the 1970s, are preserved in time. Their purpose was to demonstrate to anybody who would stumble upon them what life is like on Earth. There are 55 global greetings in various languages contained in the recordings. The variety of people and civilizations on Earth is demonstrated by these welcomes. The recorded music features both indigenous songs from throughout the world and classical compositions by composers such as Bach and Beethoven. The beauty of human ingenuity and the ability of music to unite people are both reflected in this music. In addition to the greetings and music, one may get a feeling of the nature of Earth through the sounds of thunder, birds, and whales, among other things. Additionally, there are 115 photos that depict many aspects of human existence, civilizations, landscapes, and scientific and technological advancements. That's not all, though. There is also valuable science and math knowledge in the golden records. The intention behind including this knowledge, along with data on DNA and our solar system, was to make it understandable to any sentient species. Scientists thought that science and arithmetic were universal languages that applied to all of space and time. This was more than simply a science experiment. It was an optimistic notion that we might communicate with sentient entities, even if they were light years away. The golden records capture the essence of the 1970s, when people were enthusiastic about the prospect of extraterrestrial life and reaching out to the stars. It is now extremely unlikely that any aliens will discover these documents. However, it hasn't prevented curious folks from asking. Discussions over the appropriateness of sending signals into space and the definition of communicating with extraterrestrial life have been spurred by the recordings. They now serve as metaphors for our curiosity and our desire to learn more about the world around us. They have stimulated the minds of philosophers, artists, and scientists alike, getting them to reflect carefully on the nature of humanity and our place in the cosmos. But that is not where the narrative ends. The golden records serve as a constant reminder of our common human experience even now. They stand for our unwavering ambition to surpass ourselves and go beyond. They still serve as an inspiration for fresh concepts and initiatives that investigate the potential for extraterrestrial life. Voyager 1 and Voyager 2 set the path for subsequent missions as they continue to journey. The information they return aids in our understanding of space and directs the development of future spacecraft intended for even more in-depth investigation. NASA's Interstellar Probe mission is one such initiative that seeks to go beyond of our solar system and into the interstellar medium. We will get additional knowledge about the edge of our solar system and the huge space outside thanks to this expedition. There's still more. A daring new project called Breakthrough Starshot intends to use strong lasers to launch small spacecraft to the nearest stars. The goal is to travel to other star systems in a human lifetime, testing the capabilities of current spacecraft and offering us a look at what space exploration may hold in store for humanity. NASA is also developing novel concepts that may alter our approach to space exploration. Their Advanced Ideas program is investigating methods for communicating across long distances and traveling at a quicker pace. These developments might help us overcome the major obstacles to traveling far beyond Earth, which will determine the direction of space travel in the future. But there are other difficulties as well. Collaboration between governments and commercial groups will be more crucial than ever as space exploration grows more complicated. Working together will be essential if we want to keep expanding the realm of what is feasible in space. The European Space Agency, ESA, and the International Space Station's joint efforts demonstrate how much can be achieved when people work together. Working together, we can overcome the many obstacles that come with spaceflight, and this collaboration fosters a common enthusiasm for discovery. Joining forces makes nations and agencies more resilient to the challenges of deep space exploration and expanding humankind's reach beyond our small corner of the cosmos. These collaborations foster the development of a common strategy for space exploration in addition to technological advancement. This collaboration ushers in a new era in which our natural curiosity drives us to investigate uncharted territory, a voyage that continues among the stars. Space missions are among of our most amazing accomplishments, influencing how we perceive the solar system and displaying our ambition to keep pushing forward. Voyager 1 and Voyager 2, launched several decades ago, are still journeying farther into space, carrying more than just scientific instruments. They carry the essence of human curiosity, ambition, and a never-ending hunger for knowledge. These two spaceships are representations of our common desire to explore the wide cosmos and venture beyond our current understanding. However, more than simply the information the Voyagers returned mattered. They have ignited a desire for space travel that keeps motivating younger people. Deep space research has reached a new height because of the inventive techniques and technology they created throughout their incredible voyages. Were Neptune and its moon Triton able to elucidate the existence of extraterrestrial life? How do you feel about this heavenly enigma? Remember to like, subscribe, and leave a comment below with your opinions.